Here we go. First one, a median. 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 As you read the definition, that's great. I like to remember a median with a little saying. So write it next to the definition. Here's the saying: medians go to midpoints. Okay, medians go to midpoints. All right, that's the saying I like to always have with that vocab term, median. My diagram I provided to you is a little naked right now. All right, it's a little naked because I want you to read the definition and mark the diagram appropriately. A median is a segment that starts at a vertice and goes to the midpoint of the opposite side. A median starts at a vertice and goes to the midpoint of the opposite side. So please put a couple extra markings on my diagram that is blank right now. Okay, if you know AD is a median, you should know a couple things now. Good, good, perfect. Medians go to midpoint, so we now know that segment BD is congruent to segment DC. Notice we are not putting right angles on there. That's an altitude. Okay, medians go to midpoints. That is it. It does not form a right angle. It does not form a right angle. So there's another vocab word, a median. Medians go to midpoints. All right, let's find out something about the medians. Go ahead and graph this next triangle for me. Plot the points, connect them. You will need a straight edge for this example here. There's straight edges up on the corner desk next to Connor up there if you need one, because this will not work unless you have a straight edge. And here's what we're going to do with this triangle, and you're going to do it on your own here. Right over here, guys. You are going to find the medians of you're going to find all three medians in this triangle right now, all three medians. You cannot find the medians unless you have the midpoints to draw them to. So your first job is to take each of the sides and find the midpoints and graph them. Okay, all the medians go to midpoints. Let's do the easy one first. I'll do the easy one with you, and that's going to be for side BC. We don't need the midpoint formula for there. Can you just find the middle of BC? All right, let's not waste our time. All right, let's not waste our time there. Just find the middle of BC, plot the midpoint. Let's see, it's 1, 2, 3, 4 units long, so go 2 away from either vertice. There's the midpoint. Take your straight edge and draw in the median now. Draw in the median from A to BC. One median down, 2 more to go, and that's on to you guys. So you're going to have to find the midpoint of AC, plot it, draw in the median from B. And then do the same thing for side AB, and then draw in your median coming from vertex C. We just used the midpoint formula last week, so hopefully we remember. So find the midpoint of each side and draw the median over from the opposite vertex. And hopefully you see something if you've been using a straight edge. here to finish it up. You should notice something about all three of those medians that it's kind of been the big theme of this unit so far. Good job, everyone. Good work. Draw the final median there, draw it in. And what are we noticing? They all intersect at the same point, huh? So now, this is the fourth type of line that all intersect at the same point in the triangle. Perpendicular bisectors all intersect, angle bisectors, altitudes, and now all the medians intersect. Okay, and I promise you that's going to be it. All right. All the medians intersect at a point called, anybody want to try that word? Lauren?
Centroid.
Centroid, yes. They all intersect, all the medians intersect at a point called the centroid. So the centroid is the intersection point of all three medians. And I wish we weren't on such a time crunch, because also the centroid, if we could cut this triangle out perfectly and we had a really sharp pencil tip, you could place that centroid right on the pencil tip and it would balance the triangle perfectly. It's called the center of gravity too. It just balances that triangle perfectly if you put your pencil tip right on the centroid. Not that half of you care, but I think that's pretty neat. Questions here? All right, so now we have a fourth and final point of intersection. Centroid. Circumcenter. I'm not going to play this game. You guys have until Monday to figure it out. Circumcenter, equal distant from the vertices, right? Incenter, equal distant from the sides. Orthocenter, nothing special, but if it's an acute triangle, it's inside. If it's a right triangle, it's on. Ready for centroid. This is a big one. All right, big one for centroid. Here's the theorem. We'll write it down, and I'll go back to the graph to tell you what I mean by it. So let's just write it down first. Here's what the centroid theorem is. Centroid splits any median into a ratio of 2:1. And here's what I mean. Please go back up to the triangle you just found the centroid of. I need somebody to do some counting for me, all right, to show you what I mean by 2:1. Okay, a little help here. Leo, a little help from you. I think you can count. You see point A, Leo? Vertex A, and you see where the centroid was? Where all three intersected. Can you count that distance for me from A to that centroid? How long is it? 4. Thank you. It's 4. Now, same median there. Can you count how long it is from the centroid to the midpoint?
2.
How long?
2.
Oh, 4 to 2 splits it into a ratio of 2:1. Meaning, this part right here, from the vertex to the centroid, will always be double the length of the other side. Always double the length of the other side. That's what I mean by 2:1. Everyone see 4 double 2. Also here, if we want, get a triangle here for me. Go ahead and make a triangle as a little example in the centroid theorem. So I drive this home. Call that point A for me. Draw it over to point E. Make these sides congruent because now you know AE is a what? What do we call AE? That is a median. Good. And then on AE, we're going to put what the centroid, where the centroid is. So let's just put it right about here. We'll call that point D. So make a little note here. D is the centroid. Point D is the centroid. So if, here you go, if AD equals 10, if I tell you AD is a length of 10, then what about DE? Centroid splits it up into 2 to 1. One piece is double the other piece. So if AD is a length of 10, how long is DE going to be using this theorem? Shoo, what do you got for me, Sloan? What is it? 5, yep. And the big question I always get from students is, which one's the longer piece? Which one's the longer piece? The longer piece is always from the vertice to the centroid. Okay, that is always the longer piece, from the vertice of the triangle to the centroid. All right? All right, let's use it now. Let's use it in a couple algebra examples. All right, M is the centroid. I want to stop reading. If M is the centroid, I want to use vocab. What is YO, WX, and ZR then, if they're all intersecting at M, the centroid? What are those 3 line segments called? 3 line segments that all intersect at M. What are we calling those? It's got to be, those have to be the what, Carmela? What are the 3 lines that all intersect at the centroid called? Medians. Good. All right, so if they're medians, I should see hash marks flying around your diagram right now. Give me 2 segments that you know are congruent because those are medians. Give me 2 segments. Shoo, where am I going there? Dexter, 2 segments that are congruent if those are medians. WZ and ZO get a hash mark each. Good. Give me another pair that must be congruent. Shoo. Adriana, what do you got back there? Good. And the final pair of segments that must be congruent because those are medians. Backing up a little bit, Lucia. Okay. That's what we need. You read that that's a centroid. That equals the medians. I got congruent pieces all around this diagram. We ready to roll? All right. First one, WM. WM is 16 units long. WM is 16. How long is the whole median WX? Well, we're not getting there unless I know what MX is. I don't know the whole median until I know what MX is. So let's start there. MX breaks it up into a ratio of 2 to 1. So let's start with MX. How long is MX going to be up here? 1, 7, Lola? 8, half of 16. Good job. And now all of us can hopefully confidently find the whole median WX. But I needed MX first. Needed MX. Okay, so what is that whole... going up and down here. I love it. Evelyn, how long is the whole thing? 24 units. Questions from you guys there? All right, next up, same diagram. What do I have? YM is 12. How long's YO and MO? YO and MO. I'm going to start with MO because I can't find YO unless I know MO. All right, look at the diagram. Be careful. How long is MO going to be if M is a centroid? One more up, Taylor.
24.
24, you double it, right? This part is always the longer part, vertice to centroid. So that's 24. And then now, hopefully, we're good with YO. 24 plus 12. Jane, when you're ready with YO, let me know.
36.
36. Good, everyone. Good. Not too bad. All good. And then 5, now we're going to use some X's in there. instead of just whole numbers. So label your diagram. What do we got below our medians? Well, mark your diagram first. If all those are medians, A, D, B, E, and CF are all medians. And hey, I had you mark your diagram. I know, like last problem, I didn't need to know that all those pieces were congruent, but you never know. You never know what you're going to need in a problem. Let's see, BG 2x plus 10 and GE 3x minus 1. Got it. False. False. That's false. We know both pieces aren't equal. That's false. Somebody's going to adjust it for me so it's true, though. Okay, that is a false statement. All right, it does not break it up into a ratio of 1 to 1. It is a ratio of 2 to 1. One piece is double the other. I need you to adjust it so I can solve it, because that is incorrect. I think we can all agree that is incorrect. Adjust it for me. Adjust it. Adriana, want to adjust it for me? Good. This part is equal to double the other part. If maybe I called on somebody else, you could also multiply 2x plus 10 times a half. All right, times a half if you wanted to. Your call. But this piece is equal to double the other piece. Go ahead and solve now. We're looking for BE at the end of this. BE at the end of this. Everyone's going to find X, but that's not what we're looking for. Okay, I got X equals 3. Make sure we're all on the same page there. X equals 3. All right, substitute in. And how long was the length of BE? Length of BE going deep there, Noah? 24 units. Yeah. Okay, here it is. We're finally done. Done with all the vocab. Now you figure out where you are and where you need to be by Monday. Because we're ending class with a whole bunch of review. We are going to start with number 4 first. This is not a multiple choice question. It is parts A, B, C, and D. Each triangle has line segment CD drawn in. You are going to tell me what type of line segment it is. Well, what are your options? The 4 we've talked about. Is CD a perpendicular bisector? Is it an angle bisector? Is it an altitude? Or is it a median? Not possible is not an answer. It's one of the 4. So based on the markings or the numbers I've given you in each diagram, give me your best name for line segment CD in each of the triangles. And again, your options are the 4 we've talked about. Could be a perpendicular bisector, angle bisector, altitude, or median. So I'll give you a couple minutes. Hey, discuss it with the crew around you as well, right? Discuss it with the crew around you because we got an even bigger task coming up after this one. So just start on number 4, please. What is CD in each of those? And I will ask these same questions on the quiz. Is it a perpendicular bisector, an angle bisector, an altitude, or a median? Talk it over if you want with others around you, that's fine. Here it is now, putting your vocab to use. What do we have for these 4? All right, ready to roll here. Let's see it. If you get it wrong, who cares? We're learning. We got to know by Monday, right? Got to know everything by Monday. All right, let's first start up here. A, what is CD in that diagram? Start us off right here. Come on, what do you have? That's Ed? No, I didn't, but thanks. Okay, perpendicular bisector. I agree with the perpendicular part. What does this have to have, though, if it's going to be a bisector? That would be a perpendicular bisector, right? Because bisector means it cuts it. Only has the perpendicular part. So you want to change it? Everyone, hey, I'm seeing a lot of people erasing, which is fine. Perpendicular do you guys have hash marks? And maybe I don't. No, okay. You got remember, perpendicular means okay, it forms a right angle, but the bisector would mean it cuts it into 2 congruent parts, which I do not have. I just have the perpendicular part. So what is it called from a vertice perpendicular to the opposite side? Want to change it? Okay, medians go to midpoints. This is just right angle only. We talked yesterday about it. It comes from a vertice perpendicular to the opposite side. These form right angles. Altitude. CD is an altitude. Everyone good? I need the hash marks to make it a bisector. Need the hash marks. Okay, part B. 2 inches, 2 inches. That's it. 2 inches, 2 inches. What's CD up here? Shoom, going deep here. Sam? Median. That is a median. I do not see a right angle. So it is not a perpendicular bisector. You need both to be a perpendicular bisector. I see 28 degrees in part C. What's CD now here? Charlotte? That's an angle bisector. Good. And then what I thought was going to be the toughest here, part D. Look at what is CD in there? What is CD acting as there? No hash marks. There's no hash marks up here, just a right angle. Just a right angle up there. Let's get it going. Connor, what do you got over there? That is an altitude, correct. So there was no perpendicular bisector. I need both, right? Perpendicular, I need a right angle. Bisector, I need the hash marks on the sides. Any questions on those 3? Because now it's going to get tougher. Now you're going to go through a bunch of these, and you're going to tell me what the point of concurrency is. Is it this diagram the circumcenter, the incenter, the orthocenter, or the centroid? So I'll go through the first one with you, part A, before I let you loose. You have, based on the markings, you got to know what all 3 lines are up there. So let's start there. Based on the markings in part A, what are all 3 of those line segments called? Don't give me the name of the point. Look, here's what I'm asking for. What's that right there? That's a blank of the triangle. What's that? That's also this. That's also this type of line. What are those lines I'm giving you based off those hash marks? What are those lines called there? Those are all what? Camilla, now I'll take you. Okay, but what are they though? Are they perpendicular bisectors, angle bisectors? They're all medians, right? Everyone agrees? That's what we did today. Okay, so if they're all medians, take it next level. That must mean that point where they all intersect is called the Ariella? That's how this is done. That must be the centroid. All right, see what you can do. All right, I just don't want to hand these out here. So you guys got B through F right now. B through F. What is that point of concurrency? You have four options. It's the circumcenter, it's the in-center, orthocenter, or it's the centroid. I'll be here all this week after school if you want to come in. No more vocab, I promise. No more vocab. You got everything you need now. C is tricky. Part B, what is that point up here? What is that point up here? Part B. What do you want to call that point? It's going deep there. Sloan, what is that point? In center, because I'm showing you angle bisectors in the diagram. Okay, those are angle bisectors, so that makes it the in center. All right, I thought part C was going to be tough because you had to realize I really wasn't giving you angle. I wasn't giving you altitudes, medians, angle bisectors, or perpendicular bisectors. What am I showing on this diagram? That point is the same distance away from all three vertices, right? That's what I'm showing you by the congruent marks. That point is the same distance from the vertices. So which point is the same distance from all three vertices? That's going to be the Nick. What's that? In center is the same distance from the sides. Okay, this is saying it's the same distance from the vertices, right? So what point is the same distance from all three vertices? Sloan, back to you. That is the circumcenter right there. Okay, the circumcenter is the same distance from all three of the vertices, and that's what I'm showing there. Okay, D, I am showing you these three lines are ones we've talked about, and they're all intersecting at that point. What name did you give that point, Noah? Yep, these are all altitudes, everyone. These are all altitudes. So that's the orthocenter. Whew, a lot going on the next one, huh? Whew, that looks intimidating. But if you followed, I gave you both here. Look at that. I gave you both, the right angle and the hash marks. Okay, I gave you both there. What'd you call that point there? Whew, a couple more, Eli. Guys, these are all perpendicular bisectors. You had the right angle and the hash marks. Yep. So this is the circumcenter. Everyone see that? Those three lines are perpendicular bisectors. And then how about point or F there? Shoot, a couple more down. Cadence, what do you have? That's the orthocenter. Those are all altitudes. Good work. Yep. Those are all altitudes. Okay. So first thing tonight you're going to do for me, we're going to put all this into one chart. Okay, we're going to put this all into, this is like a little cheat sheet for you. All our lines and points are going to one chart. So I will do the perpendicular bisector with you, and then I'll let you go on your own. So perpendicular bisector, your best description of what it does. Well, it definitely forms a right angle, right? Forms a right angle. And what else? What's the bisector mean? Forms a right angle and cuts a side into two congruent parts. Draw me a picture of it. Everybody should be starting with the triangle. And then show me a perpendicular bisector. It can come, from any vertice, right? Boom, boom. There you go. There's a perpendicular bisector. Make sure you have a right angle and hash marks. Where do they all intersect? What's that point called where they all intersect? Let's keep going here. Going Taylor. Where do they all intersect? The perpendicular bisectors all intersect at the circumcenter. That's where all three perpendicular. That's what I'm looking for here. Point of concurrency. Where if I drew in all three, they would intersect at the circumcenter. Yep. And then tell me what's so great about the circumcenter. Where's it equal distant away from? Circumcenter, all the same distance from, Leo? If you have the circumcenter, it's the same distance from the... Yep. So that's what I'm looking for here. And that is what I'm looking for the rest of them. So this can be like your little cheat sheet as you go into Mondays.